All right, so this is an example problem of the Pythagorean theorem topic from your ALEX topics, just in case you needed some extra help with that. So we have a problem here. It says the longer leg of a right triangle is 3 units longer than the shorter leg, and the hypotenuse is 7 units longer than the longer leg. Remember, the legs are the non-hypotenuse sides of a right triangle. How long are each of the sides of the right triangle? So I'm going to start this by drawing a picture. So let's see. Got a right triangle. And it says the longer leg of a right triangle is 3 units longer than the shorter leg. So that means if I said my longer leg is x units, because we don't know how long that is, the shorter leg is 3 centimeters, or 3 units shorter than that. So it's going to be x minus 3. And then it says the hypotenuse is 7 units longer than the longer leg. So again, my longer leg was x. My hypotenuse is 7 units longer, so it's x plus 7. So when you're reading these problems on ALEX, you just have to be careful that you know which thing it's being compared to, and make sure that you name your variables appropriately. So now I'm trying to figure out how long each side of the right triangle is. So obviously we've got a right triangle. The relationship between the sides is the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. Now, notice that x minus 3 squared, if you have seen the videos that did on completing the square, you'll know that when you square that, you have to multiply it by itself. So you're going to get a perfect square trinomial, x squared minus 6x plus 9. You would get that from foiling x minus 3 times x minus 3. When you square x, you just get x squared. And then when you square x plus 7, you get x squared plus 14x plus 49. Now, this is a quadratic equation. Everything, the highest power that you see is a square. And the way to solve that, we can solve it by factoring, we can solve it by quadratic formula, you solve it by completing the square. I just choose whatever's the easiest, and I tend to think quadratic formula is. So what I'm going to do here is combine like terms. And then I'm going to move everything to the same side, because that's what you need to do for the quadratic formula. So I'm going to subtract x squared from both sides. 2x squared minus x squared is x squared. I'm going to subtract 14x from both sides. And I'm going to subtract 49 from both sides. And then I'm going to hit the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so what I have here is 20 plus or minus the square root of 560, because 4 times 40 is 160, and we have a negative and negative, so it's plus all over 2. Now, for the purposes of this, 560 is not a perfect square. I could get an exact answer here, but since I'm talking about a length, it makes more sense to get a decimal amount. So I'm going to pull my calculator out and actually do this calculation. And when I do that, I get two answers. I get 21.83, and I get negative 1.83. Now, this is a problem in which you're talking about a length. Remember, x was the side of a triangle. There's no way you can have a negative length. So this negative 1.83 is irrelevant. It doesn't relate to the problem. The 21.83, though, is the length of my longer leg. So my longer leg is 21.83 units, and I probably should have put like centimeters or something in the problem, but I didn't. So my shorter leg was 3 less than that. So it's going to be 18.83 units long. And then my hypotenuse was 7 units longer than the longer leg. So it's going to be 28.83 units. Now, I could take this and actually check my answer by using the Pythagorean theorem. That squared plus that squared should give me this squared. But do be careful when you're checking, because you rounded these numbers. So it's not going to be exactly the same, but they should be really close to each other. Hope this helps.